Hey y'all, today we are going to build off our formula that we were starting to build up yesterday. We had a sine of bx and a cosine bx. We're adding in this plus d at the back of our formula now. So at the top of your note sheet, you'll see we have three equal signs. Let's fill these out with kind of our legend for how we use these formulas. We have the amplitude equals a. We worked on that one yesterday. The period equals 2 pi over b. That was another one we worked on yesterday. And that new one that we're introducing today, the vertical shift equals d. Let's get that up there as well. The other thing we should get down is some definitions, and this is associated with that coefficient d that we're going to be working on today. The first definition is the midline. This is something that we kind of intuitively know, but want to formalize and talk about today. That is simply the horizontal line that is halfway between the max and min. So if you look at this image below, the definitions there, you don't need to get these on your paper, but that midline is that dashed red line that's running in between my tallest peak and my lowest valley of our sine waves. So it kind of creates the symmetry that we're going to see in our waves. And the equation of the midline is simply going to be y equals the vertical shift, or y equals d is another way we can write that if you want to as well. Y equals d. And that is simply going to be, if you look at this bottom right image, how much our graph moves up or down from our vertical axis or from our horizontal axis. Yesterday we looked at amplitude, which was really about, the stretch, the vertical stretch or compression of that wave. This is all about shifting it up without stretching. So we're going to kind of build off the skill we had yesterday of finding these features from formulas. We'll have some good practice doing amplitude and period again, but we're going to add in the vertical shift and midline now. So the first thing we want to do is we have this example one. Let's rewrite it on our sheet. We have 4 sine 3x plus 2. We're going to again utilize structure. So if we're trying to find what d is equal to, that is simply this 2 at the end here. And the equation of the midline is just telling us, hey, if I were to draw a line on my graph that demonstrates that vertical shift, that line of symmetry, it's going to be at y equals 2. The amplitude. Again, that's just out in front. You guys are getting good at this. That should be 4. And our b variable is going to be 3. And so we can use our formula 2 pi over b to calculate our period, which in this case is 2 pi over 3. And in this case, we can't actually simplify it any further. We can just leave it as that. All right, example 2, we're going to get some more practice with this, so please try it on your own first if you want to, and then correct it against mine. The first thing we look for is that d coefficient. In this case, it's -1. That puts the equation of the midline at y equals -1. Our amplitude is going to be out in front of our sine or cosine. In this case, it's going to be the a is equal to -3 here. Our b coefficient is 12. That's sitting next to the x within our sine or cosine. And that puts our period formula as 2 pi over 12. We'll need to simplify that, so let's expand it out. We can do 2 pi over 2 times 6, or if you wanted to break it up into 2 times 2 times 3, that works. We can cross out a 2 and be left with pi over 6 as our period. And finally, let's do one that gets a little trickier. We have the cosine of 6x. In this one here, you'll notice that there is no plus or minus d coefficient out at the end here. So yesterday when we saw that when the variables weren't there, we assumed that they were able to be equal to 1. In this case, since the d coefficient is added or subtracted, it's almost like we are adding or subtracting a 0 at the end of it. as opposed to adding or subtracting a 1, because this adding or subtracting a 0 won't actually change the value when we evaluate it. So in this case, our D coefficient is equal to 0, and that equation of the midline is y equals 0. So we continue on with our amplitude. Yesterday, we kind of learned that, hey, if we don't have a number out in front of the cosine, since it's multiplying with the cosine, it's going to have an amplitude of 1. That b variable is going to be 6, and that makes our formula 2 pi over 6 to calculate the period. We can expand that out, get 2 pi over 3 times 2, make those equal signs a little cleaner. Got the 2's we can cross off, and we'll get pi over 3 as our period. All right, the other skill today that we want to work on is trying to find these features visually from our graph. And so what we're looking for here, first off, is we're trying to find that line of symmetry, that midline. And once we do that, everything else should be really easy to do. So we can kind of use guess and check. We might be able to see it right off the bat. We can use some counting techniques, but let me start with kind of guess and check here. I'm going to put a yellow line across where I think this midline might be to start. And let's say I take a guess at, hey, I think it might be 1. One thing I can do is I can look at that sketch line and say, hey, that doesn't seem right. It looks like my top peak, there's more space between that and the midline than my bottom, my valley there. And really, we want those to be equal, right? Because we're looking for that line of symmetry. Another thing we can do is kind of count from our midline. It takes us 1, 2, 3, 4 tick marks from the top, and only 1, 2 tick marks to the bottom. So we're clearly not in the center there. So I'm going to try that again. Let's try 2 this time because we had some space we needed to fill out top. And already I can see that that looks a lot better. So in that case, let's just do our quick counting check real quick. From 2, we got 1, 2, 3 spots moving up, 1, 2, 3 spots moving down. I think we're okay there. So our vertical shift here is going to be a positive 2. That D coefficient is going to be equal to positive 2. That puts the equation of the midline at y equals 2. And here we can visualize that a lot cleaner, right? Y is that vertical axis, and at a line of y equals 2, it means that we're always going to be at 2. It's just going to be a straight line going across, just like our yellow line is. Then our amplitude, we already kind of did this by checking our midline. We are just going to count up the distance between, so I'll make amplitude green here, the distance between that midline and our peak, or we can count the midline to the valley. Either way, it's going to be the same. In this case, it's 1, 2, 3. So our amplitude is 3 here. All right, last example before we go into practice problems. Going to kind of repeat that same process. Looking for that midline first. We can kind of hunt, guess, and check if we want to. This one I can see pretty clearly right off the bat. I think it's going to be at -1. Let me draw a line just to double check this here. Okay, I think that looks good. And if I count up, I have 1, 2 moving up to my peak and 1, 2 moving down to my valley. So I'm good there. My vertical shift is going to be at -1. Vertical shift at -1. That puts our equation of the midline at y equals -1. And then again, for our amplitude, we're looking for, all right, what is the height between that midline and that peak, or the midline and that valley? And in this case, it is 2 tick marks, so our amplitude is